Hi everyone! Today I'm going to explain dual energy CT in a very simple and intuitive way. By the end of this video, you'll understand what dual energy CT is and why using two X-ray energies gives us more information than a standard CT scan. Let's start with what a regular CT scan does. A standard CT uses one X-ray energy to create images. The image you see is grayscale, and the brightness depends on how much the X-ray is absorbed. That's why bone looks bright, air looks black, and soft tissue falls somewhere in between. Regular CT is excellent at showing anatomy and overall density. If you want a deeper explanation of Hounsfield units, check out my CT-HU explained video. But there's an important limitation. Different materials can sometimes look very similar on a regular CT scan. For example, iodine contrast, calcium, or certain types of tissue may overlap in appearance. That's because density alone doesn't always tell us what something is made of. Regular CT shows how dense something is, not its composition. This is where dual energy CT comes in. Dual energy CT uses two X-ray energies instead of one, typically a low energy and a high energy. And here, when I say energy, I really mean two different X-ray spectrum. These images are acquired almost at the same time during the same scan, which helps eliminate inconsistencies caused by motion. By comparing how tissues respond at two different energies, we unlock information that a single energy CT simply can't provide. Here's the key idea. Different materials respond differently at different X-ray energies. When we analyze the low energy and high energy data together, we can separate materials that previously looked the same. This process is often called material separation or material decomposition, and allows for more accurate interpretation and diagnosis. A helpful way to think about this is with an analogy. Imagine shining only one color of light on an object. Now imagine shining two different colors of light. The second approach reveals details that were invisible before. Dual energy CT works in a similar way. Two energies reveal differences that one energy alone cannot. A classic and very practical example is iodine contrast. With dual energy CT, we can highlight where iodine is present in the body. We can also remove the iodine signal and generate what's called a virtual non-contrast image without performing an additional scan. This means more information from a single acquisition, which can reduce scan time and patient dose. Dual energy CT is used in many clinical applications. It can help determine kidney stone composition, identify gout, and improve tumor visualization. All of these applications benefit from the ability to distinguish materials. And here's the main takeaway. Regular CT uses one energy and provides density-based images. Dual energy CT uses two energies and provides material-based information. By separating the X-ray spectrum, we gain more confidence and more diagnostic value. If you found this explanation helpful, feel free to like and subscribe. And if you want to dive deeper, I also have a video showing how material decomposition works, from projection space to image reconstruction. You'll find the links in the description. Thank you for watching. See you next time. Bye.